So for this lesson, we're working on learning how to solve a system of linear inequalities. So you're going to notice some of the concepts are going to be similar to what we did with like solving systems, in the sense that you're looking for values for the x and the y that works in both of them, but this time we're working with inequalities. So we're looking for the coordinates or the x and y values that work in both inequalities. So to kind of warm up, we're going to do some of the, I guess, a little bit easier ones, and then we'll work on some where I guess it's got a little bit more involved with the problems, okay? So if we look at number one right here, we're trying to solve this system of inequalities. In other words, we're looking for coordinates that work in both of these. So now, just kind of thinking about it, think about what this is. We're looking for, in this one, all the y values that are less than 6. So we're looking for all the coordinates that have a y value that's smaller than 6. But we're also wanting to find the coordinates at the same time that also have y values that are greater than 3. And so when you have to solve a system of inequalities, you could think through it, but remember, with inequalities, there's an infinite amount of coordinates that will work. So your job is to find all of the coordinates that work in both of these, okay? So to do that, you're going to graph them. So if you think about the lesson yesterday, to graph them, you need to start by thinking about this like a normal equation. So we're going to start by thinking of this like it's y equals 6. And we're going to graph that. So y equals 6, if you kind of remember that sentence, this line is one of those special lines because it doesn't have the x and the y in it, so it's a constant function. And so the way that you read it is that this line's going to hit the y-axis at 6 and only 6. So you go to the y-axis, 1, 2, 3, 4, 5, 6, at 6, and you put a dot, and you kind of have to think about it. Remember, these are the ones that are either going to be vertical or horizontal lines. And so if I think through it and I think to myself, okay, it's only going to hit the y-axis at 6 and nowhere else on the y-axis, well, if I draw it vertically, it's going to hit the y-axis everywhere. So that's not what I want. So that means that this is one of those horizontal lines, okay? So now before I can actually draw my line, remember, because this is an inequality, you need to go back over here and look at what kind of line it's going to be. And if it does not have the little equals to underneath it, then that means it's a dotted line, which means that you're not going to include the coordinates that this line goes through. So, because they're not going to be solutions to your answer. And if you think about that, that should make sense because we're looking for all the coordinates that have a y value that's smaller than 6. And so the coordinates that are on that line would actually have a y value of 6. And so you're not wanting that, okay? So now we're done with that. So I'm going to erase this because we don't need that anymore. It's not really part of my problem. It was just to help me graph it. And now we have to shade. So you can choose a test point like you did in the other videos. But if you kind of think through this, this should make sense. We're looking for all the y values that are smaller than 6. Well, think about all the points that are down here. Think about all the points that are up here. Like if I choose my test point 0, 0, well, think about the y value of 0, 0. The y value is 0. So plug that in. Is 0 less than 6? And yes, it is. So that means all the points that are down here are going to be the ones that have a y value less than 6. So you're going to shade below it. So I'm just going to draw kind of lines. Just make sure that you know where all the points are, all the coordinates are that work in that equation. So there is my shading for that one. And now, the only difference for today is now you are going to have to graph this other line on the exact same graph, okay? So when you're shading, I would not shade super dark because you're going to have to graph another line on the same graph, okay? So now we're going to graph this one. So for this one, we're looking for all the coordinates that have a y value that's greater than 3. So start by graphing it like normal. So y equals 3 is what we're going to graph. So this line's going to hit the y-axis at 3 and only 3. So I'm going to look at my graph. I'm going to go to the y-axis to 3, 1, 2, 3. put my dot, and then I'm going to think, how can I draw my line, because this is another special one because it doesn't have the X and Y in there. How can I draw my line so that it only hits the y-axis at 3 and nowhere else on the y-axis? This would be another line that would have to be horizontal. So before I draw it, I'm going to look over here. It doesn't have the little equals to underneath it, so that means that it's a dotted line. So you're going to have to ignore your other graph while you graph this one. So notice I'm kind of just ignoring my shading because it'll mess with me if not. Okay, so that is the line, and now we have to shade that one. So for this one, so again, ignore the other line and everything that you did for the other one, okay? Because if not, you're going to be confused in a second, okay? So we're looking for all the y values that are greater than 3. So with this one, you're going to look at this line. You're going to pick a point either above or below. And so I'm going to just pick the point 0, 0. And I'm going to plug that in. And I'm going to see, does that work or does it not? And if it doesn't work, then obviously we shade the other side. If it does work, then we shade the side that it's on. So if I'm just looking at the y value here. So if I plug a 0 right there, is 0 greater than 3? And no, it's not. So that means that I have to shade on the other side. So 0, 0 is down here. So that means I have to shade above that line. And we're shading above this one. So that means I'm going to draw the shading sideways so it looks different. Everything that's above that line that we just drew would be an answer that would work in this one, okay? Now to actually solve it, you're going to look for where do they overlap. Well, if you look at this region right here, this is why I kind of drew my lines going different ways. This is the part where they overlap. So any coordinate that's in this region would be a solution to that system of inequalities, because all of these coordinates are going to be the ones that have y values that are less than 6, but they're also going to have the y values that are greater than 3, and that's what you're looking for. And you could check it. You could pick a coordinate that's in here and double check and make sure the y value is less than 6 and greater than 3. And so that's how you solve. And I would actually darken in that part where they overlap so you can make your answer clear. Okay, so let's do a couple more like this, and then we'll do some where you're graphing the ones that have a slope to them. Okay, so number 2, we're looking for, in this system of equations, all the x values that are less than 7, or all the coordinates have an x value less than 7, and all the coordinates that have a y value greater than 2. Okay, so start one at a time. We're going to start by graphing this one. So we're going to start by graphing the line x equals 7. So this line is a constant line too because it doesn't have the x and y. So we're looking for the line that hits the x-axis at 7 and only 7. So I'm going to go to the x-axis this time. 1, 2, 3, 4, 5, 6, 7. Okay, I'm going to think, how can I draw my line so that it only hits the x-axis at 7 and only 7? And these are the ones that, again, are horizontal or vertical. If I draw it horizontally, it's going to hit the x-axis everywhere. I don't want that. So this one has to be vertical. And then we look, does it have the equals to underneath or not? And if it doesn't, then, like this one doesn't, you draw your dotted line, because that means all the x or all the values that are on that line will not be part of your solution. So there's my dotted line, and then we have to shade. So you're looking for all the x values that are less than 7. So you can kind of think through it, and these are your x values, right? So think about the numbers that are this way and think about the numbers that are that way, and you could probably figure out which ones are the ones that are less than 7. Well, that would be this direction. If you didn't realize that, you could pick a point, like you could pick the point 0, 0 and plug it in and see if it's true. But you would be shading this way. So we're going to lightly shade on this side of the line and make sure we kind of cover the entire region, because in order for us to solve these systems of equations, we're going to have to make sure that we know where everything's being shaded. And I usually try to draw my lines going one way so that I can easily see where they overlap in a minute. Okay, so there's that. So any coordinate that's in this region right here would work in that inequality. Now we're looking for which ones would also work in this one. So now we graph this one. So I'm going to graph it like normal. So we're looking for the equation y equals 2. So that hits the y-axis at 2. So I'm going to ignore the other graph for a second. I'm going to go to the y-axis at 2 and put a dot. I'm going to think through it. It's going to hit the y-axis at 2 and nowhere else on the y-axis. So this one's your horizontal line, okay? And it doesn't have the equals 2 underneath, so this one's also a dotted line. So draw my dotted line here. And then we've got to think about how to shade. And again, you've got to ignore that line you just drew so you don't get confused, okay? So we're looking for where all the y values are greater than 2. So you can think through it and look at your y values and think about which ones are greater or above this or higher than this number right here. And you could probably figure it out. Or you could take your test point 0, 0 and plug it in. And if it works, then you shade that way. If it doesn't work, you shade the opposite way. So either way, you would actually end up shading above that line because the y values that are bigger than 2 would be up here. So you shade above that whole line. So again, you ignore your other graph. I know that's going to be hard, but you've got to ignore it so that you can shade this way. And then you look at where they overlap. So if you look, they're overlapping right here. So that means any coordinate that's in this region right here of that graph would work in both of those equations. And so that would actually be your solution to that system of inequalities. Okay? So let's do one more. So number 3, you're graphing and finding the solution to for where all the x values are less than 2, but also you're looking for where all the x values are greater than 5. So start by graphing them. This would be like the x equals 2 equation. So I go to the x-axis at 2 and put a dot. And then it doesn't have the equals 2, so this is a dotted line. Now these are the ones that hit the x-axis at just a certain point. So these are vertical. So, because if we drew it horizontal, it'll hit the x-axis everywhere. Okay, so there's that line. And we're going to shade, so make sure you shade before you move to the next one. So where are all the x values less than 2? Well, less than 2 would be this direction. So we're going to shade everywhere in this direction. So that any coordinate that's in this side of that line would work in that first inequality. Now we're going to graph the other one and see which of those would work for this one and then look at where they overlap. So we're looking for all the x values that are greater than 5. So we're going to graph x equals 5 first. So go to the x-axis at 5 and put a dot. 1, 2, 3, 4, 5. This one doesn't have the equals 2. So it's dotted and it's a vertical line because it's x equals a number. So put your dotted line. And now for this one, we're looking for where all the x values that are greater than that. So if you look at your x-axis, and you can choose your test point if you want to, but if you look at your x-axis and you think about the numbers that would be in this direction, so this is 5, that would be 6, 7, 8, 9, so on and so forth, versus all the ones that would be in this direction, so this would be 4, 3, 2, 1. Which ones are greater than 5? Well, that would be in this direction, so that means you shade this way. So any coordinate that's on this side of that line would work. And then to find the solution to the system, you're looking where they overlap. Notice they don't overlap. So if there's not an overlapping section, that means there's not a coordinate that will work in both of these. And if you kind of think about it, there's not an x value that's less than 2 and also greater than 5. So that should kind of make sense. But if they don't overlap, then your answer is actually no solution. Okay, so look out for those because you will get those from time to time.